Alright, welcome back to the channel. Today's a little different. We're going to be doing some C programming. So I wanted to write a program in C for doing a sorted linked list. It was assigned by the technical interview class I'm taking, and I thought it'd be fun to do it in C, so we're going to try to do it here. I've done it before, but I'm going to see if I can do it without looking at my notes or anything. So let's make, well, first of all, let's do a directory here called linked list, and we're going to make a list C file in our linked list directory here. Okay. This should be fun. I don't think I've done C on the channel before. So let's go ahead and get started here. We need to include our standard io.h so that we have printf, and then we need to also get our standard library, so we have stuff like malloc. Okay, so we're going to be building out a node which is a number and a pointer, essentially. So let's do a type def of a struct node here. And struct node, and we define it as an integer of a number, and we want a pointer to a struct node, so it would be a struct node pointer to the next node, and then we want to call the struct just node here. So we've got our node struct now. I think that's how you do a struct. We'll find out. So our main program here is going to be int argc char star argument vector array. And then I always think that this is like the hardest barrier for looking at C stuff sometimes, but all this is saying, this is our main function. It's going to have argument counts, which is how many command line arguments, and then the argument vector is going to be which actual string is the argument. So in our main program here, we're going to say, we can do some checking. Like we can say if our argc is smaller than 2, they need to provide some command line arguments, right? So we can say printf, we could say please provide numbers as arguments. Okay. So after we do that, we can we need to make the node from the argument vector. So I guess we need a node pointer, so we can say a node pointer called list. We're going to assign it to null. So list is the head of our linked list. Then we're going to loop through our argument count. So we're going to say for int I equals 1 and not 0, because 0 would be the program name. So this will start at the command line arguments, other than the program name, for as long as I is less than our argc. And then yeah, we're cycling through our argument count. So we need to extract the numbers from the argument vector. So we're going to give ourselves a number, and we're going to pull it. We're going to use the a to I function so we can convert the ASCII value into an integer. And what we're converting is our argument vector array at index I. Is that right? And then we need to allocate some memory for our node that we're going to be inserting. So it's going to be a node star called n, and we're just going to malloc a size of node to be our memory here. Okay. So we've got our number, we've got a place for our node. We're going to check if n is equal to null, like we ran out of memory, or don't have memory, we can return an error. Okay. So here's where we need to actually assign the values for our nodes. So we're gonna do our n number is gonna get our number that we extracted, and our n, I'm trying to do touch typing here, our n next is gonna be assigned to null. That's how we're gonna tell if we're at the end of our list. If we're pointing to null, then we're at the end of our list. So we cycle through our argument counts. We're gonna assign the number value to the node that we created, and then we need to go about inserting it, and we can see if we know that if our list is null, then there's no linked list in our list yet. There's no node in our list. So if that's the case, then list is going to get equal to n, our current node. Then we can say else if either there's no node in our list, or possibly we need to prepend this node to the beginning of our list, which would mean that if our node's number is smaller than the list's number, then we need to prepend it. So if our number's smaller than the list number, then our node needs to point to the current head of the list, and the current head of the list needs to point to us now. Then we can do another, this is for everything that's not, the very beginning of the list. We need to traverse our list to see where it goes, because it's a sorted linked list. So we're going to insert it into the correct spot, hopefully. So actually we need to do a for loop for traversing our list. So we're going to say we get a pointer of node, a node pointer, assign it to the head of our list. the condition in the for loop is for as long as the pointer does not equal null, we're going to say in the afterthought pointer gets advanced to the next pointer. Okay, so I like thinking excuse me, thinking about it like it's easy to append a node, right? Append a node if we're at the end of our list and we haven't found a number bigger, then we just need to append it. So we're going to say if our pointer's next value is equal to null, then we're just going to have our pointers, the end of our list will now point to our node instead of being null. And then hey, Google Smart, what's up? We're doing some C programming today. So this is if we need to append the node to the end of the list because it's bigger than every other value. So now we need to find if we need to insert our node anywhere in the middle of our linked list. So we can ask if our node's number is smaller than the pointer's next number. So we're trying to figure out where to insert it into the linked list, right? So if our number is smaller than the next numbers, the next node in the list's number, then we know we need to insert our node here. And we do that by saying, well, now our node is going to point to what our pointer, to point to that bigger number essentially. And then we're going to reassign our pointer's next to now point to us. Is that right? So if our node's number is smaller than the pointer's next number, then we are going to point to that bigger number, and then we're going to take our current number. Let me think. Yeah. Our current pointer is now going to point to us. Yeah, I think that's right. Cool. So this might insert it, but we need to give some feedback to the user. Hey, Google Smart, I'm doing good. Yeah, this is a different kind of stream. Something I'm working on to prepare for a job interview. So I'm hoping I can pull this off as part of practice for that. This should be all of our list insertion logic. So now we need to print stuff to the screen. So let's give ourselves another for loop where we traverse our list. So we're going to give ourselves a pointer to the head of our list for as long as the pointer does not equal null. We're going to assign our pointer to be equal to the next pointer. I have not tried to compile anything on Windows Subsystem for Linux, so I'm hoping GCC works. We'll have to see. Okay, so we're going to cycle through, and then we're just going to print out. We're going to printf the value. Now we put our format specifier for an integer, followed by a new line. and we insert the pointer's number value into our printf. Hey, thank you for the follow. I didn't see who that was. Thank you for the follow. Yeah, we're doing some C programming today. Different than the normal. We'll see how it goes once we go to compile. Now we need to we need to free our memory we assigned for the linked list. So let's give ourselves, we could do it in the for loop here. I kind of want to do it a slightly different way to practice. Like if we give ourselves a pointer here, we can do a while loop instead. So we're going to say we get a pointer to the head of our list, and then we're going to do a while the pointer does not equal null. We're going to do a thing here where this is a little tricky because we can't, if we free our pointer, we lose the reference to the next node. So we need to store the next node before we free it. So we'll say pointer next gets stored inside a next. Then we can free our pointer. And then we can say pointer now gets assigned to be our next. And then it should go ahead and free all the pointers until pointer is equal to null. So until we reach the end of there. This might be it. Let's see if it compiles. Let's see. I don't think I messed up the struct node definition. Let's see if we compile. So let's do this, and we're gonna say, let's go into our linked list folder. There's our list.c. So let's try to compile this. We'll compile it with the name of list, and we'll give it the list.c. No errors. So let's try it. ./list, we'll run it, and we did a /n. We can fix that. But that's good, though. That means we compiled and it's working, so we just need to put \n here that I missed. And then recompile it. So let's do our GCC. TAC-O means make the executable named list. And then let's try to run our list. Okay, please provide numbers as arguments. Okay, so .list, ./list, and we'll give it 1, 2, and 3. And it looks like we are in a loop. So let's go try to figure out where we messed up. Okay. All right, we pull our number, we assign a node for ourselves. We initialize them. If there are no nodes in our list is just going to be the single node that we have. If our node's number is smaller than the very beginning of our linked list, then our node is going to point to the beginning of the list, and the beginning of our list is now going to point to our node. Otherwise, we cycle through, we traverse our list. Oh, and you know what? We didn't put a break here. That might fix it, but let's see. Yeah, if we're at the end of our linked list, we're going to append that node, and if our number goes in the middle of the list, then we're going to put it pointing to that bigger number, and then the previous number is now going to point to us. Then we break that loop, and then we should print the value of each node, and then we should be freeing it as well. So let's try this now. Let's do... Okay, let's recompile. And we'll rerun it. /list, and we'll try 1, 2, 3. Okay, it's still busted. Maybe I didn't. Let's try to remove list and then try to recompile it. We're still busted. We're still printing infinitely. So the printing is right here. So unless we are... It looks like it was just printing 2 over and over and over, huh? Oh, I'm sorry to hear that, Google Smart. Hopefully he gets better soon. Or she gets better soon, yeah. Or he, yeah. Hopefully that works out okay. Okay, we've got to be messing up here somewhere, I think. Our number is smaller than the next number. We are going to point to that bigger number. Yeah, our node is going to point to the number that is bigger. That sounds right. And then the number that was... I feel like I'm messing up here, but I'm not sure. Okay, I'm comparing my notes now. This is looking right so far. Yeah, I'm not seeing what I'm doing wrong compared to my notes. We're stuck in an infinite print, so maybe the print... Oh, that's exactly how I've got it in my notes. Yeah, I mean, I'm not seeing an issue here. It must be a tiny typo I'm making. haven't ever tried this compiling in GCC on Windows Subsystem for Linux. I don't know if that's the issue. Hey, yeah, Google Smart. Hey, thanks for tuning in. Yeah, I appreciate it. Well, we weren't so successful, but maybe I messed up the node struct. No? Type def struct node. Yeah. Let's try it again. I mean, I don't... We have the break, so when we compile this, I thought the break was the issue there, but yeah, clearly broke. It's gotta be in inserting it, right? Let's check. We snag our number, convert it to an integer. Yeah, we get a size of node malloc. We assign our number. We nullify our next pointer. If our list is empty, our list gets... Oh, you know what? No, this is still right. If our number is smaller than the first head of the list's number, then we point our node to be to the head, and then we point the head to this node. Yeah, so we point to the old head of the node, and then the new head of the node is now us. Else, for pointer gets list, as long as pointer is not null, we traverse. Yeah, I'm not seeing... There's one missing curly brace, I think. Curly brace, curly brace, curly brace. Yeah, I'm thinking there's... Oh, we do need to end our for loop here. We need to end our... right? Yeah, we need to end our for loop. There we go. I think that's it. Oh my goodness. Okay. Maybe we'll try this again from scratch. So it's not so messy. But this is okay. This is what we need to practice. Okay, we're going to recompile. our list from our list.c. Maybe not. Maybe I didn't. Oh, this. I think this was wrong. I think this is wrong. And that's what we need. Let's try that. Okay, we compiled okay. Let's run our ./list. Please provide numbers 1, 2, 3. There we go. We've got our list. And then if we try to give a different order, 5, 2, 3, whatever, it ordered it there. Okay. We've got our linked list working. Yeah, we just messed up our brackets. We just messed up our curly braces, which is typical. I kind of want to try it again, see if we can knock it out. Let's try it again. I'll try it again, and okay. So let's try it again from scratch, and we'll say we'll make our file name here list.c. Let's. What? Did we just bring that thing back from the dead? Okay, we've got our list. Okay, let's try it again. Let's include our header files. Standard io.h gives us printf. And then standard library gives us a to I and malloc. Okay. Type def struct node. We need a number, and then we need a struct node pointer to the next node. And then we're going to call this struct node. Okay. Int main. We have our argument count and our argument vector, which is an array. I'm going to do some checking here. And if argc smaller than 2, we're going to go ahead and print some usage. Okay. Now, let's give us the pointer to the list. Let's call the list head this time. So we're going to initialize it to null. Then we're going to cycle through all of our argument counts. So it's important to start I at 1 here so we don't copy the program name. We just get the arguments we want. For as long as I is less than the argument count, we're going to go ahead and increment that I. And then set that up. Okay. Okay, so we're cycling through our argument count. So let's go ahead and snag our number. So we're going to convert the ASCII into an integer, and we're going to pull it from our argument vector at index I. Then we're going to malloc us a pointer to a node called n, and we need to malloc a size of a node so we get the right amount of memory. Then we do a little malloc thing to be safe. If n is equal to null, if malloc returns null, we just want to quit our program because there was no memory. So we'll say return 1 here. And then we need to initialize the variables here. So we're going to say our node's number is going to be the number we extracted, and we're going to set our next pointer to be equal to null. Okay, so now that we've got, now that we've got that made, we can ask if our list is empty. So if our list is pointing to what we initialized it to as empty, then we're going to say, well, now list is going to be pointing to n. Yeah, and it's not list, it's actually head. We changed it to head, so we can say if the head is null, then the head is now n. And then, yeah, this is where I was messing up the parentheses here, but else if, actually, no. Outside of that, you know, if the head's empty, the list is empty, we're just going to say the head is now this node. You know what? Yeah, I guess we can do the else if here. So else if our if our nodes that we're trying to insert, if that number is smaller than the head's number, we need to prepend the node. So okay, if our number is smaller than the head's number, then we need to prepend it, and that would mean that our node would point to where the head used to be, and the head would now point to us. Is that right? Yeah, we would point to where the head's pointing to, and the head would point to us. No. Yeah, if we want to prepend it, yeah, we point to where the head was. Yeah, I think that's it. We just point to the head. Is that right? We point to the head and the head points to us. Why would... Man, I'm getting stuck again. Yeah, so how would we prepend the node to the list? We have a head in there. Our node would need to point to the head, because the head is the second thing. Oh, yeah, okay. And then we reassign the head. So like this makes the current head the second object, but then we need to reassign the head to be equal to us now so that the head's updated to where we are. Okay, that makes sense. And then else we can traverse our list here. So we're going to say a node star pointer gets our head. We start at our head and we go for as long as pointer does not equal null. Pointer gets pointer next. And then we're traversing. I like to do the end first. So like if our pointer next is null, we know we're at the end. Therefore, we need to append our node. And all we do to do that is say pointer next now points to us. Break. And then we can say if our pointers, or if our node's number, we need to find where we insert it. So if our node's number is smaller than the pointers, I cannot type the angle brackets without looking. Next number. So if our node's number is smaller than the next number, we need to insert our node there. And we do that by saying our node is going to point to that bigger number. And then where we used to be pointing is now going to be pointing to us. I think that's right. No, we need to point, pointer next gets us. I think that's right. Yeah. Okay. And this is where I messed up last time. I need to make sure to get outside of all of these curly braces except for that one. And then this is where we traverse to print. So we're going to do this, and we're going to say do this again for int. No, it's not int. It's a pointer to a node. So node star pointer gets our head. We start at our head. For as long as our pointer is not equal to null, we're going to advance the pointer. And then all we have to do is print out what it is. So printf, put a %i for integer, followed by a new line, and the thing we're putting in there is the number that we're at. So I want to try to free the memory in this loop while we're at it. I think we can do that. So why don't we go ahead and print the number, but then what we're going to do is we're going to save the next, because we're about to free this pointer. I think let's try it. So we're going to give ourselves a pointer to the next node, and we're going to save it from the current pointer's next value. Then we're going to free the pointer, and then we're going to assign pointer to be equal to the next value we saved. Oh, I think that might screw up this advancement. Yeah, we might have to split it up. I don't think this assignment, since in the body of the for loop we do this, I don't think that'll work. Let's see if that gives us a weird issue here. Okay, GCC. It compiled. It wants the numbers. So 1, 2, 3. Segmentation fault. Core dumped. Yeah. Good old seg fault. Okay, so yeah, we freed it incorrectly. So let's try. Let's do this separately then. So we print them up, and then we're going to ask for a pointer that starts at our head. And then we're going to go for while that pointer does not equal null, do something. And we want to save the next value from our pointer here before we free it, so we don't lose access to the linked list. Then we're going to free that given pointer, and then we're going to assign pointer to be equal to next. And that should be it. So let's do the other split here. Okay. Okay, we're going to recompile. Okay, ./list, we're going to say 1, 2, 3. We've got 1, 2, 3, good. Now let's do 2, 5, 4, 3, 1, 6, 8. 1, 2, 3, 4, 5, 6, 8. Cool. We've got it. Okay, so that wasn't bad. The thing that got me was the curly braces for this part. But other than that, and then the break on this part on that first time. But I'm feeling pretty good about being able to do that. So I think a good thing to try next is to try to do maybe a doubly linked list. And then we can do some, I can work on maybe some different challenges, like can we reverse sort the list? Can we just do different stuff with it? So that might be fun. But I'm going to call that a night for now. At least we got some C programming in. Hopefully it wasn't too unbearable. But thanks for watching, and I'll be back tomorrow. I'll probably do game dev tomorrow instead of C. I will be doing a lot of HackerRank stuff to prepare for my job interview and stuff. So that'll be just, on my own time. But thanks for watching, y'all. We'll raid out here. We'll go over to Hypnotic, because that's just what I do. Thanks for watching, y'all. I'll catch y'all tomorrow.